Okay, so today we'll be solving the 11th question of the exercise 2.1 of the book Challenges and Thrills of Pre-College Mathematics. So the question states that if m, n, p, and q are non-negative integers, prove that summation of n minus m p plus m factorial divided by m factorial, where m is the integer that is being iterated upon up till q, is equal to p plus 1 factorial divided by q factorial into n divided by p plus 1 minus q divided by p plus 2, right? So to prove this, we'll be inducting on q. We will take the base case as q equal to 0 since it has mentioned that non-negative integers. So base case q equal to 0. When q is equal to 0, we have only one term in the left-hand side, that is n minus 0 into p plus 0 factorial divided by 0 factorial. On the right-hand side, we have p plus 1 factorial divided by 0 factorial into n by p plus 1 minus 0 by p plus 2. Right, simplifying both sides, we get n into p factorial is equal to p plus 1 factorial into n divided by p plus 1, which is essentially equal to n into p factorial. So the base case satisfies. Now, for the inductive hypothesis, let us assume that this is satisfied for all non-negative integers n less than k plus 1. So let's substitute n equal to k. So we get summation, sorry, not n. We're inducting on q, right? Q for all non-negative integers, q less than k plus 1. So we have, so we'll substitute k instead of q. So summation to k, m equal to 0, n minus m, p plus m factorial divided by m factorial is equal to p plus k plus 1 whole factorial divided by k factorial into n by p plus 1 minus k by p plus 2, right? So for the inductives, so we have m equal to 0, k summation n minus m p plus m factorial divided by m factorial plus, this is the term that we'll be adding, n minus k plus 1 whole p plus k plus 1 divided by k plus 1 factorial is equal to p plus k plus 1 factorial by k factorial into n by p plus 1 minus k by p plus 2, right? So, and we have to add the extra term. So the extra term is n minus k plus 1 into p plus k plus 1 by k plus 1 factorial, right? Now on the left hand side, essentially this becomes summation m equal to 0 till k plus 1 n minus m p plus m factorial divided by m factorial, right, is equal to, we'll take p plus k plus 1 factorial by k factorial common, so we have p plus k plus 1 factorial by k factorial common into n by p plus 1 minus k by p plus 2 plus n by k plus 1 from here, this n minus k plus 1 by k plus 1, essentially. Right? Now, let's let the LHS be as it is. And let's take LCM over here on the right hand side. We get p plus k plus 1 factorial by k factorial. So LCM will be p plus 1, p plus 2 into k plus 1. So this will be n into p plus 2 into k plus 1 minus k into p plus 1 into k plus 1 plus n into p plus 1 into p plus 2 minus k. Yeah, well, write it down. So minus k plus 1 into p plus 1 into p plus 2, right? So let's combine the terms that have n. Like let's try to take something common from these two terms. Let's try to take something common from these two terms, right? So we have p plus k plus 1 factorial divided by k factorial into, when we take common, we see that we have n into p plus 2 common, and we get p plus k plus 2 here, right? And then minus, because we added the p plus k plus 2 is because we added p plus 1 and k plus 1, right? And then the minus, um, we can have k plus 1 common and p plus 1 common, and remaining we get k plus p plus 2, right? Now from both of these, what we can do is we can take p plus k plus 2 common. And when we take it common and we multiply to this, essentially it becomes p plus k plus 2 factorial by k factorial into n into p plus 2 minus k plus 1 into p plus 1, right? And also we forgot to put the denominator there, so we'll just add the denominator now. So the denominator will be p plus 1 into p plus 2 into k plus 1. Apologies for messing that up before, right? So there's the denominator. Now we can take the k plus 1 here to the k factorial, so we get p plus k plus 2 factorial divided by k plus 1 factorial into n into p plus 2 minus k plus 1 into p plus 1 divided by p plus 1 into p plus 2, right? And essentially what this becomes is p plus k plus 2 factorial divided by k plus 1 factorial into n by p plus 1 minus k plus 1 by p plus 2. And the LHS is the summation m equal to 0 till k plus 1 n minus m p plus m p plus m factorial, yeah, p plus m factorial by m factorial. So this essentially proves the inductor step, and by principle of mathematical induction, we have proved the statement. Thank you.